I'm going to do 3, 2, 1.
Right, and we are live. Welcome, everybody, to Introduction to JavaScript Unit Testing using Angular. That's the title is so long I had to reduce the font so it would fit on the slide. But today we're going to go through and talk about some unit testing basics as it relates to JavaScript, how that's implemented in Angular. And then we'll go some basic examples, demos, and walkthroughs. And so if you have any questions along the way, feel free to drop them in the chat just to make me as monitoring and interrupt accordingly. I don't really have a huge set of demos. We'll walk through these samples in whatever sequence. So if you have questions, again, feel free to interrupt. All the things that we go over today, including the slide deck, this GitHub repo. If we go out real quick, over here, and it looks like this. So you should be able to pull it down. It's public, nothing crazy. So you can run these, go through the tests, as well as the PowerPoint deck is out here as well for reference if you want it after the fact. So with that, just to set the stage, these are always challenging to figure out what the common audience is going to be, which exposure that we have with the ones like Angular, JavaScript, for unit testing, or developers. And so we're going to go through a little bit of foundation, unit testing stuff, a little bit of the foundational Angular stuff very briefly. And we'll do to try to do that. I built and start talking through some of these examples. So first of all, unit testing, what we're trying to do is test a small, very small piece of our code, a specific unit, right? So most commonly, this is going to be a method or a function. From the purest testing perspective, each unit test would correspond to each publicly accessible function within your application. Some of these today that I'm going to show have sort of skipped a little bit and combined more than just one thing, just in the interest of time and demo and that sort of thing. But so we want to keep that in mind, that unit testing is a very, very small piece of functional code. And so as we look at each of these tests and the files and we go through all the components, we're focusing on the system of their test. So from the Angular perspective, we may have a component which represent a web page. We're going to have some services, which are like our AJAX calls and the wrappers. And some other Angular components, such as a directive and a pipe. So there's just some of these. In that context, the system under test is going to be scoped, and it makes it pretty handy the way they create it, because each test file or spec file that you'll see represents a system under test for the demo today. And so if we think about, I'll walk through this in a little bit for the first test, and then as we go through other examples, I'll stay over it just because it's repetitive. Think about phases after a range or set up the tests that we need. Our components, we need a system under test to be in known state so that we're able to test it. So we're going to arrange, and then we'll act, which is actually the execution of that function or the method. So for example, a call that will create a user, which will be one of our tests. And then we're going to assert or verify that the component acted the way that we thought it would, and that the state of our class or the state of our system under test is what we think it should be. So conceptually, this is what gets a lot of people, if you're new to unit testing, and hopefully, based on the title, an intro to unit testing in JavaScript, maybe this isn't new to you, but if it is, conceptually, the unit test versus the integration test is very important, because a lot of times when folks are new.
Hey, Jeremy, your audio keeps going in and out. Do you have a headset handy or something?
Maybe. Actually, let me switch off. I want to join us. Give me 2 seconds. All right, I think it put me in as an attendee. Can you unmute me on the other phone, Justin?
Yeah, I can hear you through the.
Yes, audio better, not better.
Yeah, sounds good.
I think it's back on the computer, so, but I'm in on the other one if we got to switch. All right, sorry about that. Hopefully, testing, integration testing. We conceptually.
Oh, never mind. You're back to garbled.
Okay, hold on.
Now you're totally muted. Yeah, still muted.
Okay, now. So, I'm meeting it's in Linux online. All right. Now.
Yeah, still a little garbled. Are you in as a attendee? Maybe if you leave that.
Let me see. It put me in. It won't let me rejoin in two places, I think. Let's see. Produce.
Sounds good.
Okay, nothing's changed, so fingers crossed. Integration testing. So the concept here is that a lot of folks ask me how to test my database, for example. So this is we're going to get into this integration testing structure, and there's a lot of pieces that are. So we'll talk unit testing. We're sort of going a little of that, and so there's a lot of design patterns out there that exist for things like that. So dependency injection, version control, things like this allow you to abstract your database access into your repository. So the way that we can test the interactions and speaking with frameworks like that or maybe framework work as the design is what we use. So for today, we're going to go to the unit testing side and we'll show you this around AJAX calls, making HTTP requests and things like that, because we have to have these responses in known states. So conceptually, we can talk about this a little more if there's questions when we get to the demo. I just wanted to pause and point out these differences so that we're on the same page as we go to review some of the tests. So another concept in JavaScript specifically, which is the Angular testing framework, is mocking or spotting as JavaScript calls it. So what this allows us to do is to, during our unit test, look at the way our components are interacting. So if we make a call, we will verify that two components are interacting properly. For example, we have a service that makes an AJAX call. Spies is a mechanism that allows us to ensure that our components or various systems are interacting in the way that we intend. So the tools that we use, Jasmine is a common JavaScript testing framework. This is what Angular sort of supports out of the box. And so when you use the CLI, and that it actually creates these Jasmine tests for the templates for each of these test files automatically for you. So you'll be seeing the syntax in a little more detail as we walk through various use cases. And then the actual test runner is called Pharma. Again, this is just the toolset that Angular has adopted into the box. And so everything there's sort of is very easily replicatable into an existing Angular class sort of guaranteed. So in this demo, show how Pharma produces for us and how Jasmine actually happened. And then all the pieces I'm going to go through are documented here on the Angular site. I want to switch over real quick, but to show that you can see that all these concepts, coverage, testing your services, components, all the various pieces in a lot more detail will be here than I could cover in the remaining 45 minutes or so that we have. But the menu and the documentation is very good. So use the Angular site as a resource if you're trying to incorporate this into your own projects. And then lastly, what we're going to be covering today, components for the services space, building blocks of the application. And then we'll also talk through some common questions around how to debug these tests. And code coverage as a concept is very useful that Carter and Jasmine work together to show us how much of the Angular code is actually covered in our tests. Those holes may be, so you can consistently build quality software. So that's all the foundation I'm going to go through. The next will be codes and then more fun to watch. Paul, very briefly, any questions out there before we move on?
Nothing. Your audio's still going in and out every now and then. Like sometimes it'll be completely fine, and then it'll dip back down into being garbled. I'm thinking it might be your microphone on the computer.
And of course, all I have is a Lightning headset handy. I'll move a little closer just in case. Good. So, quick demo of the app. This is again fairly contrived for purpose of today. So we're going to walk through this. Nothing fancy. It's not going to box off. Got a couple of pages to go talk to this. On this whole page here, we have just a few different text strings. This highlighting here is ran by Angular Directive. And this formatting is done by the Angular pipe. So we'll talk about how to test these as well as the page in general. And we've got a couple of pages. This page pulls a random jump from the Shift API. And so we've got some tests around this. I see that it refreshes, and then we have a simple form that would create a user that uses a different API. So this is what we'll go through in testing those. So the app is fairly straightforward. And then when you look at the structure, a very quick tour. So this is just an Angular shell that was created with the Angular CLI. And then from that, we'll go down through a few components. So the home component, which is the one that had the funky text. We've got these services here. These are our Ajax wrappers that we'll test. The pipe is down here at the root and in the main application. So throughout, you'll see that just the way Angular organizes the code, it creates the spec file in the same folder or same location as the corresponding markup, controller, and then style sheet. So it should be fairly easy to follow along if you pull down this repo after the fact and run accordingly. So with that, in the CLI, the only thing we have to do to run the test, I'm going to run all switch and we'll walk through what we see. Test. It'll be the output of the console, and it's also going to open up a browser window. It will show the test results, and then it breaks them down by the tests, and we'll fix them. We'll begin to break them apart. So, a couple of things here. You'll see that first, that little box that just popped up was actually the result of another unit test. Things in this web page here is generated by Karma, which we mentioned was the test runner. And then this output is what is produced by Jasmine, which is actually responsible for running the tests. So we'll walk through these. As we talked earlier about system under test, you'll see here's the about component, here's the pipe, and it sort of walks through in a very user-friendly format I'm thinking this is test output, which we'll get to in a minute. So the app component is the main shell, and then these represent the tests for each component that we wrote. So with that, we'll just pick the home component, just the page, walk through a few samples that I'll put back and forth. So again, all of the test files are component.spec, and then Angular does use TypeScript if this is a new language to you. But a few pieces will walk through sort of the setup. So describe the home component. Again, Jasmine is included with this considered behavior-driven design framework versus your more traditional TDD or test-driven development sort of record-blowing model. And so this gives us the goal is a more declarative syntax. And so look here at the home component. This is used for how life groups a single home component, and then down below, I say the first text should create, should set output, etc. So this is how it automatically runs through our test files and gives us a more user-readable, more user-friendly format. So a couple pieces. These, if you've seen other unit testing frameworks, these will be fairly common or should not be super unique to you. But the concept of before each, so this would be part of your setup test phase. So it iteratively runs and it spins up separate threads, although I know JavaScript is still single threaded, but it runs each test in its own memory space. And so it's going to set up these declarations, the test fixtures, walk through these in more detail, and then it's going to run the test. So if you look, these are two different tests, and they're defined in Jasmine with it, and so it, and then what will it do? So it should create the component, it should set the output, etc. So this is the boundaries of each unit test. So if you were to look at this or think about this in a linear format, the before each would run, before each, it should create, and then again before each it should set output, before each. There's also an after each. There's some single setups as well. In the goal of the unit testing is that we always know the state, and so the order doesn't matter. And in fact, every time Jasmine runs, they're actually ran in a random order, just to make sure that we're not doing something that we shouldn't do amongst our tests. So that's a sample. And then if you think back to a slide from a few minutes ago, arrange, assert, act. So or arrange, act, assert, that's another order. The assertion here in Jasmine is an expectation. And so the way that assertions work is if it's true, code proceeds, if it's false, if there's an error, and that's how you define if your test passes or fails. And so this expectation here is when it runs the component, it should be hello world. All right, and so this is looking at a variable on my component, which looks like this. And so you'll see that it's just, this is the simplest of tests, again, for a contrived example, that I have a variable on my class called output set to hello world. And then when I switch back to the spec file here, it just validates that that is indeed true. If I were to change the value, the test would fail. So I'll illustrate that very quickly. I'll just set it to hello world. See here in the console output, it will fail momentarily. And then in the UI, it'll show you exactly why. So home component should set output, so that way you can debug and diagnose your test. And it says it expected the actual value to be hello world. So if I go back and I change it back to hello world and I click save, the watch is running in the background here, the Angular CLI, and so it goes and it reruns my test, and you can see that they've all gone back to green now. In terms of the randomized test, if I refresh this, this may not always work, but you see that it had a joke for you. That was one of the pages, and as it goes back through, so now you can see that it's hidden behind here, but it rendered the create user page. And that's again because of just the random nature of the test. So whatever UI component it happens to run last is the one that gets shown on the screen. So a few more examples, very simple ones. We can check
numbers, right, to be a specific types. We can check strings, and then
we can begin to filter through the raw HTML. And so here, this selector allows us to use CSS style selectors to find a specific and make sure that it exists on the page. So this may, from building testable code, we may need to provide specific selectors or identifiers, things like that, in our markup to make sure that we can actually validate that the elements are there, that it will be removed by mistake, or somebody's making another change to the restructure of the UI. As we should have a series of tests that would fail
until we get them wrapped around our new UI. So this one here, we are checking output, all right? And then this is conceptually worth walking through very briefly. So there's an element called currency output. And so if we look here, this first one, and it's referenced by ID. I'll put them side by side, maybe it'll make it easier to follow along. So the currency output, this is a type built into Angular that formats a numeric data type into a formatable string. And so there are ways to enable these multicultural, multi-region, which is the second example here. But regardless, we take the number that in our component here, the same value, this variable is just to this, what have you. No programmatic interaction here. This is just a simple example. We want to make sure that this numeric data type in our component is rendered in the formatting that we set up. So that's where we can check, number one, that this test validated the data type is what we thought it was. And then this test validates that the formatting, when it gets rendered in the UI, is what we intended it to be. So we
have lots of different random examples here. This one we're highlighting has to do with change detection in Angular and the way that it works. So I set a number again. It's just a variable by default in JavaScript. And so as I set this number, I'm going to make sure that it rounds right again, testing the formatting of the currency type here. And so I set it to 154, and then it does not round up to 16, and the actual string that's rendered was correct because some of this has passed. If I set this to fail, and then likewise here, just other date types that are these long ones over here. So see date wrapper, and then it gets the type. So there's this concatenated string in my UI. And so by operating on the underlying DOM, I can get it in check. That's how we format dates. Again, pretty straightforward. This is not super exciting, but it will get better momentarily. But as we look at the home page here, just again pointing out this is what some of that output was. So any questions so far makes sense. We dig into a couple of the other components. All right. So the next thing I want to show is how we test. So this highlighting is done by an Angular directive, an attribute directive specifically. So there's a couple pieces of this code up and this runs. So walk through here at the home page. I created a control directive called that highlight. So when I add this attribute to the element, it's going to make it yellow. And I'm going to test that it
works. And so if I look at the directive, a couple of things that it does, it's very, very simple. But we've got a color that can be passed in. And then what we do is if there's not one, it just defaults its value to yellow to that highlight. But I can go there if I go straight. We'll say that suddenly the yellow is going to flip the green here just a second as soon as the compile is done. So we visually see what we are demoing. Now, once it's rebuilt, so see that I can pass in green. I can make this blue. So you can see the various ways that this directive works. And then again, if I get rid of that color attribute, it goes back and now it is yellow. So I want to just simply test that this directive works the way I intended. And so here in the first example of the home component, I needed to manipulate some of the DOM elements. Well, if I go to my highlight directive, so again, there's the code, it's pretty straightforward. And when I look at my test file, we'll see that instead of using my home component, what Angular allows me to do is to set up a test component. Basically just inline in this test file. I don't have to do anything super complex. And so I wanted to test two scenarios very quickly. So I have an element that I expect will be yellow, and then an element that should be set to green. And so the before each here is going to set this up. And what I have to tell my test harness in this declaration is to create my test component, which only has these two tags in it, a very simple test and a very simple component. That's a checkable through. So make sure, number one, that my component didn't get created correctly. And so this is handy if you're doing directive testing. The Angular framework gives you the ability to find all elements on a page or whatever component you're testing that has a specific directive applied to it. And so that's this highlight directive. And so it validates that there are two of them. And that's what I would expect here and there. If I were to change the number, the test would fail. Now as I get in, I can begin to do some further inspection of the DOM and the way that my directives have manipulated it. So the first is that I can use a CSS query to find an H2 element. And then that's the first one. And then the H3 element is the one that I expect to be green. And so I can just validate that my directive is operating in the default state, which is yellow. And if I pass in a color, which is green, then it's going to work and set that color. So I'm able to test this directive without needing any sort of access to the UI. So that's a directive test. The other one on the home page here is this goofy formatting. And so I just wrote what an Angular pipe, I'll show you the code, that's going to take any string and then format it to alternating lowercase and uppercase characters. I don't know that you need to do this in the real world, but it's a simple contrived example. So I applied it here. So when you look at the home component, you'll see this pipe right here called alternate caps. And so this pipe right here, it takes a value that gets passed in as a string, and then if it is an even number, it's going to uppercase it. If it's an odd number, it'll lowercase it. Pretty straightforward logic. To write that test, again, I wanted to test 2 or 3 scenarios. So one is that it can take just regular text and make it look funky, so it'll make it look like that. I can take an all lowercase string and it's going to alternate. I can take it all uppercase string and it would alternate it. You may come up with other scenarios as you're dealing with your real world tests, which you'll see that again it gets broken together. It's broken up into components here, and so I can look at my cat pipe tests and they're all green to prove that it's working right. If I were to make a change and I make this lowercase d, for example, then when the test reruns, you see that it fails and it says it was expecting it to be that. Here's what it got, and you can compare the two to see that I need to make the D capital again. So those back. One other note or one thing to show before I forget one here is that if I need to debug my JavaScript to see why my tests are failing, Carbon gives me the ability to switch this into debug mode. If I hit F12 and go into the developer tools, you'll see that the services here are more like a production mode. And so I can't really get into any of my source code very easily. It doesn't really expose it simply. When I click on debug, it'll flip it over to debug mode. And again, this is a karma feature. And when I again, go into the development tools here, I can go into the Webpack files, which is where Angular distributes the source code, and then I can put breakpoints into whatever I'm testing. So we can use the pipe as an example. So here's my pipe code, and if I can't
Figure out why my code, maybe the value is wrong, I've got my logic here with the even odd wrong. So let's do it for the breakpoint, and then when I go to refresh file, you'll see that as it gets called every time, it's going to break in. So you can see the first one passes the date. This is the first test that I could do.
The app run. So this pipe is on the home page. There's a bunch of homepage tests, and then eventually it'll get through to some of my other pipe tests here. So here's one of them, my all lowercase test. So I could walk through this and see exactly what's going on. So that's how you debug, and then you could get into any part. You can debug the unit test itself, or you can debug the underlying code across the board. So that's testing a pipe. So we've done a directive, a basic component, and we've done this pipe.
So there are some building blocks. Not as fun, not as much of a overall test. So we can move into the overall and the things that matter the most. We want to talk about interacting with services and JSON. So I look at it, my app here, excuse me. It's still running in the background.
May not be. So let me switch real quick back to a compiled version. And I'll show you two of the pages that have some AJAX interaction. One is if you think back to the joke code, and then the other one is a page that creates a user. So I'm going to go ahead and run the test in another window so that we can keep both of them running. We'll give it just a few seconds here to regenerate. And I'll show you the next chunk of code that we're going to walk through. Oh, this is a unit test. This is my ng test running. And here, so here's my test. So the first one that we'll look at is this create user. So this is just a simple form, fill out some stuff, and then you click create. And it says define users, blah, blah, blah. So this is just an error from this service. It's a free API that I found. But it returns an object that looks like this. So it's a very simple form. This is a very common use case that we'd want to test in the real world. So when I look at the file, this create user component, you'll see that this is the markup that represents my form. Not a lot of HTML here, name, job, email, and some validation errors. And then when I look at the component itself, this is an Angular form group. This gives me an object that I can test against. And then we've got the error messages that I want to test, if I cancel, if I create. So all of these methods are candidates to be able to test. And so when we look at the spec file, just some of the things, again, we set up our testing module, or just like we normally do, so before eaches. And then some of these are fine. So what we want to do is make sure that our email property is a form control, for example, because we're interacting with the form library. And then when we go to get error messages, right? So we have different error message states. So I'll put this one over here and we'll go side by side very quickly. So some basic error validation. We've got, click the wrong file, there we go. So we see that get email error message. And so this is a thing that we want to, that's the wrong file, sorry, here. And so when we look at the error message logic, we have an email error, we can say if it's required, we want to do this, and then if it's not a valid email, we want to do that. And so here, this test, my email to an empty string, so it'll fail the required validation and validate that these error messages match this error value to the account. And then it's not a valid email. I need to write a test that allows me to get past this block. So I need to set a value. But I know that this is not a valid email address, so it would fail and say not a valid email. So these are fairly straightforward. There's not a lot of magic here, but where it gets more interesting is when we go to create a user. So this test is going to be for this create method. And so just a couple of things to show is that we make two different AJAX calls. This is just the way that the API was designed. And so we have the create user call and we have the register call. So we need to make sure that we're testing both of these. And so the first thing I need to do is fill out my form. And so the Angular form library makes it easy to write testable forms and testable UI. And so I set my name, my job to Jeremy and janitor. This is the first time we've seen spy. So this is a Jasmine construct. And what it allows us to do is intercept at runtime interactions with some other code. So for example, the create service. And so basically what this is going to do is when I call create, it's going to ensure that I call the create user method of my service. And so this is the code and this is the method. And so this is the chunk of code that I want to make sure executed the way I intended. So it creates the component and then we say, hey, we want to make sure that it was called with these parameters, right? And so I set them here. And then when I get a response back, again, this is testing the mapping here. It says that the name and the job are what we thought. And so when we look at my test file, this is in the create user one. And so when I go find create user, here's the ones that shows that it that they all passed. And so if I were to change these values, it would generate a failing test. But what's important conceptually here to take away is the spy on. This is how we spy on a method, and then we can validate in our test that it was called with the parameters that we thought it was. As we come down here, just a couple of examples. We can also test an error condition. And so in my stub here, I'm going to create a user. So this one's going to be successful. Just in my simple demo, there's no error handling on this one, which is a bad design, but I wanted to show something easy here. So here, if it's an error, it's going to capture that error in my component, and then this is a Angular component called snack bar that pops it up. That's the little box you saw on the test output. So when we call register in this case, what I'm going to do is actually this an observable, which is the RxJS library that's used extensively in Angular. And this is a whole other topic that we could talk about for a while. So what I'm doing in this case is setting up to say, hey, whenever the component called service.register, which is this API service here, I want you to, instead of returning a success response, return an error response. And so I've stubbed out, this is the format of what an HTTP error looks like in Angular. And so I'm going to make sure that number one, I did call register, and so this one would pass. And then I also want to make sure that this part of the handler got invoked over here, and as a result, it set my error message on my component. So this is the second expectation. So that's how that works. So you can easily test the service wrapper. So to look at the API service, generally speaking, you're going to want to abstract your HTTP calls into a more testable component. So this is, you'll see there's only two methods on this API service class here, and they simply just both pass through these calls to the HTTP library. So this is going to post to the user's endpoint, and this one posts to the register endpoint. And the main reason for that is testability. So you'll see in this case, I don't really have to worry about the underlying HTTP call as I'm authoring unit tests for this component. I just need to make sure that my component is interacting with the service the way that it should. And that's where the spy comes in pretty handy. But then to go one step farther, I do have tests around this that make sure that these methods are calling the HTTP methods or the AJAX calls or the REST APIs, whatever you're integrating with, in the manner that you want to. So if I look at this spec file instead, or this test, just walking through a few pieces here, we can make sure that obviously the service is created, but it introduces a couple of new components. So one is the HTTP client, and the other one is the testing controller. So these expose, they're documented on the Azure site, but these expose interactivity or interactions that allow us to test underlying HTTP calls without actually calling out to the server. So if we're doing these unit tests on the server and continuous builds and whatever, we don't want to be creating real data and what have you. And so these two components are specifically the testing controller, intercept all those calls, and wrap them in a testable format. So the before each has been altered just slightly. Number one, we have to import the module, and then we get an instance of the client by calling testbed.inject, and then likewise testing controller, and then the API service. So when you look at the API service, the code for that, you'll see that it takes an instance of the HTTP client. So this is the real one. This is the AJAX one. This is what we would use in the production version of this app. But what this test bed allows us to do is it actually will use the testing version of that HTTP client instead of the real one, because we've injected a controller, and so it intercepts all the requests so that we can examine them. So this just validates that the component is fine. It can be created. As an example, is that I call out to create a user on my service, and again, I'm testing the API service. I want to validate that it's calling the endpoint that I intend, that my URLs are right, not that the endpoint is working the way that I think it is. So I create a subnumber request and response. This is just the structure that the API needs. Here I'm listening to or spying on my create user method, or so I call it out, and then I subscribe to it, and this is what issues the request. So I'm just validating that this test object, again, just stuff out that I have to have my API in a known state. So it calls create user to make sure that the response is right. The value of this test is it says, hey, I'm going to call create user here. Make sure that I actually issue AJAX call to API/users, and also make sure that I'm using the post verb. And then when I call flush with this response object, this is then will call my subscriber. So this flush call allows me to control what my unit test is going to get as a response. And then the controller.verify no other pending HTTP request that I didn't expect. So this combines more than probably should a single test. There's no closer related illustration, so it makes it easier. So just to recap, I'm calling my service method. It creates a user. In return, I'm actually testing that it's interacting with the REST API in the way that I intend. So if the issue is a call to this URL, it's using the post method, and then it's going to actually respond back, so I can validate that that interaction returns the data that I'm expecting. So that's the way that an API or an AJAX call, some REST endpoint, can be easily tested in Angular. Cool. Any questions? I got one more thing here.
That's the log.
Come again? You said okay?
Yeah, no question.
All right, so the last thing that's worth noting that Karma and Jasmine allow us to do is analyze code coverage. And so if I do ng test and then code coverage, this is going to run through my test suite. It's going to examine all the code within my Angular app, and it's going to spit out a nice HTML report that lets me go into each individual component and file to say exactly what is and isn't covered. And so you'll see that there's an output, and then in the interim,
is running the test, just simply seeded karma. And you'll see a different output here. It's going to show some greens and possibly yellows. So you'll see that
in my Angular application, I have 97.8% of all the lines of code covered. Now, code coverage by itself isn't going to show me that my tests are actually good and valid, but it's basically just going to show me that I'm at least exercising every line of code. So I've worked with clients that say 85% is their target. After that, it may reach the point of diminishing return as you test out all these edge cases that may never actually happen.
But there's a little more to it. We're saying, what if I need to actually make it better? Or how about the way this coverage isn't? So in my Angular app, it creates a folder called coverage. With code coverage, and it creates files. And put it my coverage folder. I can open index.html. It's going to show me what is covered here. So 100% of source folder.
But more importantly, these individual files. So app, create, user, home, joke, navigation, etc. So I can identify where areas may exist. If I drill into, you'll see that home is 90%, it's the least. So if I click on the link, it'll show me the things group, which is just the TypeScript files that's tested. And then see here that I am missing a test that covers the onKeyUp functionality from the UI that is probably not even used because it's the console.log. So this could be a refactor exercise that says, hey, this method is no longer used. We pulled it on the UI, and it must be just clean it up, or keep on and test that will actually trigger this event to make sure that any logic and functionality happens.
One example of resolving code coverage, if I look at the create user spec file real quick.
I put some tests in to bump the coverage. So no, create user, click the wrong file. And so I'm testing some of these services at the end. I want to show you what the code coverage will do. Now, notice in the background, I just made some changes and I saved this file. I didn't tell it to rerun again, but it automatically regenerated code coverage because it's watching the files as I'm working through this. So it can be pretty handy. So if I go back to my coverage file, now it should be updated. And it looks like it, yeah. So you'll see here that create user dipped to 80%. These green bars are configurable. Down at the root of your file, you have a Karma configuration file. Angular creates this for you. There's hundreds and hundreds of options, but part of the options around code coverage are configured in here, could be added in here to add or remove wherever you want the red and the green bars. And you can actually, I've had some clients that have configured this to where if you don't measure 85% code coverage, for example, the build will fail. It's a great user. See that it highlights, and so it gives us some insight. Hey, there's 7 times that this code was hit in your test suite. This line only hit 1 time, just like this one, right? So that makes sense because there's 2 tests, and so it hit the 2, and this method is covered. But now here's one that says cancel is not covered. Hey, when I get into create now, I'm not testing that I'm calling this API method at all. So it's a nice quick visual indication of where your code's at and how it may need to be tested. And most importantly, from the design perspective, you may find that you're using some patterns that make your code not very tested. And so you're not actually able to get in and figure out what's going on. So that is basically the overview. If you put in the repo, this is my email address. Feel free to drop me a note and we can get together, or I can help out with whatever questions you may have. We have just a couple minutes. Anything else anybody may have before we wrap up?
I don't have any new ones.
Very good. Well, with that, thank you very much. Enjoy the rest of your afternoon. Have a fantastic weekend.